Hi, welcome back. Last time we had built this initial prototype here on a solderless breadboard. And this is great for swapping in and out components and doing little tests. There's no soldering required, but it's not very permanent. So it's very easy to accidentally bump or move or pull out components like this, which will disrupt the circuit. So really, in the long run, what we want to do is build something a little bit more permanent and sturdy. And we can do that using a soldering iron and a PCB, or printed circuit board. And you can see that this is laid out similar to my solderless breadboard, in that there are rows of connected holes. Okay, so this side that has the shiny copper, that's the metallic side. It's surface mounted, so the electricity runs on the top of this surface, and it's running in the middle here horizontally, and then on these rows here it's running vertically. Then we even have some holes here that are separated, and another row here where it's running vertically. So we have quite a few possibilities here for the way we can insert components and control the flow of the electrical path. So if we flip the board, on the other side this is painted white to also indicate the direction that the electrical pathways are connected. And this is actually the top side where we're going to insert the components down into this side. And on the flip side here on the bottom is where we're going to solder their legs into position. So this time instead we're going to be soldering in these 8-pin IC sockets into the PCB instead. And that way we can plug and unplug the 555 timer chips out. That way if we accidentally blow out a chip, we can just pull it out with a pair of pliers and stick it back in. So the legs of the chip won't be permanently soldered. This guy will be permanently soldered, and then we'll be able to feed the chips in and out of this guy. So I usually like to start out by making sure that I have space on the board for all my larger components. So I'm going to put this guy in. This is where the 555 timer chip will go. And I have two of them, so I'll just make sure that they're kind of equidistant apart from the edges. So that'll give us space. I just gave myself 7 rows from either side here, and I'll just put those in the middle. And what we're gonna do is we're just gonna kind of hold these with our finger, and we're gonna flip the board like this. And we're gonna carefully set it down like that. So the little legs of this guy are actually sticking up. Okay, so it may be a little bit difficult to see, but here there are the legs sticking up from the IC 8-pin sockets here. So I've already gone ahead and heated up my soldering iron. So I'm going to start by heating up the leg of the socket here. And I'll just put the soldering iron down up against that leg. And then from the opposite side, we're going to feed in the soldering wire. So now I'm going to move to the far leg just so I can stabilize this. And I'm going to place the soldering iron here on one side of the leg. And then we'll go ahead and feed the soldering in from the opposite side. So one of the things I'm being careful is to keep the solder all within the same area. I don't want to feed solder in between these rows here. So I'm keeping the solder on these vertical rows like that, and I'm not allowing solder to bridge horizontally across these connections. Okay, I've got the first chip done there. Now we can move on to the other chip. So if we flip this guy over, you can see that the top here has a place to put my 555 timer chips. I can insert them into here. And then you can see that their little legs are sticking through to the back side here. And I've gone ahead and soldered those carefully. And now we have these additional 2 slots here, these rows where we can connect additional wires off the legs of the chip. Okay. All right. So the chips themselves, we're just going to wait to insert those. There's no need to have them exposed to the heat of soldering all of these other connections around the legs. So we can just leave these as a placeholder for the chips, and we'll go ahead and wait till the end and we'll insert the chips in here later. So the next thing we'd like to do is insert our 500K potentiometers. So next, let's go ahead and solder on the next biggest component, which is going to be our potentiometers. Okay, so the pots that I have, these guys have legs that'll actually mount directly onto the surface of my PCB. You might also have pots like this. And if that's the case, if they have a large leg that will not fit into the PCB, what you can do is you can use a set of needle nose pliers to wrap a wire through this hole and around this leg, and just get a nice snug fit, clamp it down with the pliers, and then you're going to use the soldering iron to actually solder the wire to the connections here. So for this schematic, the only thing we need to do is solder one wire to the middle leg and another wire to either of the outer legs. Okay, but so the ones I have are surface mountable, so I only care about these 3 legs here. So I'm actually going to solder these guys directly onto the board. So in order to solder on my potentiometers here, I'm going to make use of my 3rd arm, which is this guy. So it's basically just a little metal block that has some alligator clamps on it and my magnifying glass here. And what I'm going to do is I'm just going to clamp this thing upside down the way I'll be soldering it. So I'll go ahead and put an alligator clamp on each side of the board, just like that. And then I can flip it upward like that. And we can just go ahead and insert these pots here. So there will be one there, and there will be another there. So I'm just gonna, for now hold these guys in place. And I'm going to flip it down like that, kind of like a tabletop. So I can go ahead and solder in each of the 3 legs. Now I only really need access to 2 of the legs, but in order to make this guy stronger, I'm going to end up soldering all 3 of the legs here. These guys attached there, and we can give it a test. I'm going to take it off the 3rd arm, and we can flip it over like this, and we can turn the knobs. And I was a little concerned only having the 3 legs soldered there, but it seems like it's okay as long as I don't bend this too much. So the next biggest component here is I'm going to move on to the switch. Okay. So here's the switch that I had wired up previously using the solderless breadboard. And what I'm going to do is I'm going to make sure that these wires here are wrapped around tightly on each of the 2 legs. And then I'm going to go ahead and solder these wires to the legs first. There we go. And we'll clean the soldering tip and put it back in its cradle. So there's my switch, on off, going to 2 wires with the ends crimped here. This switch is going to wire up our battery. We have our 9-volt battery, and it has some wire leads to the snap connector here. I'm going to take the battery off, make sure that I just have this connector, like so. We're going to go ahead and take the black or the negative terminal from this battery, and we're going to solder that to the board here. So you can see that I have these rows in the middle that run all the way horizontally. So you can see that's these 2 rows here in the middle that are actually bridging underneath the chip. So what we're going to do is we're going to run one side here to the negative of the battery clip. So I'm just going to feed this guy through like that. And what you can do on the other side here, where the little piece of wire is sticking out, is you can kind of push it with your finger and bend it to one side just to get it to stick a little bit. Now I have the negative voltage here of the battery from the black wire is going to be running horizontally here across this entire row. Okay. Now for the other row, which is going to be the positive, this bottom row here, I'm going to take one side from the center wire from my switch is actually going to run there instead. Now the other leg of the switch, I'm going to run into this row right next to it, like so. And then I'm going to run the positive leg of the battery into that same row. So these guys will share a row. Okay, so here I have my on-off switch. And here I have the positive of the battery going into the same row as the left wire on my switch. And then when I switch this guy toward the center like this, it's going to complete the circuit and allow electricity to flow from this red wire up through my switch, down through the orange leg, to this center row here on my board. The negative terminal of the battery is going over to the other leg there. So I don't need to connect the battery yet. I don't want to expose the battery to unnecessary heat or anything. Just like the chips, we're going to leave the chips and the battery disconnected until the end. Start to go around each leg of the chip now. And I'm going to use the Atari Punk console schematic diagram to start off with leg 1. So leg 1 on both chips goes directly to the negative voltage of the battery terminal. Short wire and run it from the leg from this row here going to the first leg on the IC socket to this row here. And I'll do the same from this one to this one. Okay. Perfect. So there's leg 1 is done. So now we can move on to leg 2. So the first 555 timer chip, it gets a 0.01 microfarad capacitor, and the legs of the capacitor bridge between the negative voltage of the battery and the pin 2. Okay. So let's go ahead and start off with the first chip, and let's find our tiny 0.01 microfarad capacitor. Okay. And set that between leg 2 and the negative terminal of the battery. So for now, I'm just going to leave these legs sticking out, and we'll trim these off at the end once we make sure everything's working. Go ahead and move on to the next connection, which is between pin 2 of the first 555 timer and pin 6. Okay, so we're going to go here from leg 2, the open hole on leg 2 here, like that, and we're going to bend around and then go in, and then we're going to bend around the chip, and we're going to go in leg 6. Now, one thing to be aware of when you wrap the wire around like this is we are covering up pins 3 and 4. Now, pin 4 has one connection from it, so I can use this other hole here, and pin 3 has one connection from it, so I can use this hole here. So it should be okay. So that takes care of pin 2 on the first 555 timer chip. Now, pin 2 on the second 555 timer chip is actually a connection between pin 3 of the first 555 timer chip and pin 2 of the second 555 timer chip. So let's go ahead and run a short wire from 3 to 2 on the second 555 timer chip. So there's a wire running between 3 over here to 2. So that takes care of legs 1 and 2 on the first 555 timer chip, as well as leg 3 on the first 555 timer. Now let's move on to leg 3 on the second 555 timer. So according to the diagram, leg 3 runs to a 10 microfarad capacitor, a polarized capacitor, and then it runs from that polarized capacitor to the positive input on an 8 ohm speaker. Okay, so I'm going to go ahead and make a bridge from leg 3 on the second 555 timer to the input leg here on my capacitor. So this is my 10 microfarad capacitor, and you'll notice one of the legs is longer. That is the input leg. And then the output leg is the shorter leg that also has a stripe on it that's a little minus symbol. So you want to go from the long leg of the polarized capacitor here into the third leg of the second 555 timer chip. Now the second leg here, the shorter leg, is going to go into an empty row. So I'll just go ahead and use a row that's next to my chip here that's not in use. Right like that. And we'll go ahead and push this guy down in there like that. There we go. So the second leg is going into this row here. So this row, the other side should be the positive input of the speaker. So we can go ahead and find the speaker now. and it has leads on it here. The red wire is the positive lead, and that will go into the row with the other side of this polarized capacitor. So we'll go ahead and stick that in there like that. Now the black wire on the speaker here is going to go to the negative terminal of the battery, which in this case is this bottom stripe that's running underneath the chips here. So I can just go ahead and attach that to this bottom stripe here. So that goes ahead and takes care of leg 3 on both 555 timer chips. Now we can move on to leg 4. So leg 4 on the first 555 timer chip goes straight to the positive voltage of the battery terminal. So we need to go from leg 4, which has one available little hole right here. So we have one available hole here for leg 4 right here, and that's going to go up to the positive terminal right here. Okay. So we'll just get a short wire to go in between there. So what we can do is we can take a short wire and you can kind of bend it in the shape or the direction you want it to head, like that. And we can insert one leg here into 4 and the other leg here carefully into the top row of the positive battery terminal. We'll go ahead and do the same thing for the other one here. We're going to go from leg 4 and just kind of like bend this guy up like that, and it's going to go into the positive terminal voltage. Okay. Alrighty. There we go. All right. So next, so that takes care of legs 4 on both 555 timer chips. The next leg, leg 5, is empty. Neither of the chips have a connection on leg 5, so we can move on to leg 6. So leg 6 on the first 555 timer chip, we already connected one from the row of leg 6 to leg 2, but it also has a 1K ohm resistor that bridges between 6 and 7. So we can go ahead and find my 1K ohm resistor, which should have a brown, black, red stripe on it, like so. And we want to make sure that this guy is inserted between 6 and 7, here and here, on the first 555 timer chip. So we'll insert that there like that. Okay, so when we pulled the legs all the way through, the resistor will sit right against the board like that. And on the opposite side here, we have the 2 wires, and we just want to make sure that they're each bent in different directions, like so. Now for the other second 555 timer chip, there's also a connection between 6 and 7, but it doesn't need a resistor. We can just use a little short wire. So I've already gone ahead and made a very small wire, and this one I'm going to use needle nose pliers to place because it's so small. In fact, So that's this guy. It is a tiny little like staple shape, like U-shaped wire that's just going to bridge between 6 and 7. So I can go ahead and insert this guy right here like this. There we go. So there's just a little staple there between 6 and 7. Okay. There we go. We have our little staple there, our little wire through 6 and 7. So this side has the resistor, this side has a little tiny connector. Okay. So additionally, on leg 6 here, on the second 555 timer, we also have this running to a 0.1 microfarad capacitor and then to the negative terminal of the battery, which is this row here. So we'll go ahead and find our 0.1 microfarad capacitor, which is this guy. And we're going to run one leg into leg 6 of the second 555 timer. And we're going to run the other leg to the negative voltage here. So again, that's from leg 6 to the negative terminal, which is this stripe here. All right. Okay, this thing's starting to look pretty good. Now on to leg 7. So aside from having leg 7 bridge between 6 and 7 here and here, leg 7 also runs to the middle leg of our 500k ohm pot. So here we have the 500k ohm pots. And this will be our first one. We'll run to this chip, and this would be the middle leg here. It's going to run to here, which is 7. So that's running from the middle leg here to the 7 there. So we'll go ahead and solder this guy in place first. Then we'll run the positive terminal, which is here, to the first leg of the pot right there. So that takes care of the first pot. Let's go on to the second potentiometer. And here we want to run the middle leg of the second potentiometer to leg 7 here of the second 555 timer chip. Okay, I went ahead and made kind of like an S-curve shaped wire going from 7 to the third leg here. All right. There we go. All right, now I need to run a wire from the first leg to the positive here on the positive battery terminal stripe, which is that top one there. Okay, so I just ran a wire from leg 1 to the positive stripe here on the battery terminal. So that takes care of pin 7 of both 555 timer chips there. The only thing left now is pin 8, and pin 8 on both 555 timer chips just goes to the positive terminal of the battery. So that should be pretty simple. We just need to go from this hole here over to the positive terminal of the battery here. There we go. So leg 8 of the first 555 timer chip to the positive stripe here on the battery. So we'll do that one first. Now lastly, we just want to make the same connection here from pin 8 and over here to the positive terminal of the battery. Okay, there we go. All right. Well, ladies and gentlemen, I think that's probably it. Let's give this guy a test. So the first thing we want to do is we want to insert the 555 timer chip. And remember, in order to line this up, let's zoom in here. So in order to line this up, we want to make sure that the notch here lines up with the notch here. So if the notch is on the left-hand side, then the bottom leg is leg 1. So we want to go ahead and insert that into there. And the way you want to line these up is you want to be careful that all the legs are going into the holes first before you try and push it down. So sometimes you might need to wiggle it a little bit back and forth, or you might need to bend the legs out. But you shouldn't have to push too hard. You should be able to push down just snugly, and it will go right into place like that. Okay. So let's go ahead and grab the second 555 timer. Okay, now this one's a little different. Instead of having a notch in it, this one has a little dot. So it may be a little bit hard to see on camera here, but there's actually a dot right here. So that means that this is leg 1. So remember, we want to line up leg 1 of the chip here with leg 1 of our circuit here. So again, we just want to delicately insert the legs into position. There we go. And then we'll just delicately press down until it snaps into position like that. Okay. Now, making sure that none of the wires are crossed on the bottom, we're going to plug it in. So I'm actually going to kind of pull all of these wires straight up. Some of them I had pushed them over. I want to make sure that none of them are crossing. They should all be standing straight up, just like porcupine quills, because I don't want to short out my circuit by allowing one connection to cross over into another. There we go. Lastly, we want to snap the battery on into place. So I made sure the switch was in the off position, like that, turned away from the center pin. And then we want to use this clip here to clip the battery on. So So we'll just go ahead and clip the battery on. All right. Now we just want to flip the switch. And we got some sounds. Excellent. So we're going to flip it off. So if you're having trouble getting yours to work, you can take a look at the troubleshooting video, which will show you how to use a multimeter to go through and check your connections. Fortunately, mine's producing sound, so the only thing left for me to do is to trim the wires on the back. And I can go and trim off any of these extra wires. Okay, so now if we look at this from the profile view, you can see that there really isn't much sticking out from the bottom of the board there. So don't forget to turn off your soldering iron. You don't want to leave that on and cause a fire. So as soon as I know my circuit's working and I'm done soldering for the day, I'm going to make sure to flip off the soldering iron and unplug it. Okay, great work. So the next step would be, if you wanted to, you could mount this guy inside of an enclosure. You'll notice that there's nuts and washers on the tops of our potentiometers. So you can take those off. You can drill a hole the exact same size as the pots and feed that through into, anything really. A box, an Altoids tin can. You can also use like a plastic first aid kit like I did. Or you can go out and buy an actual enclosure, plastic enclosure for a circuit. And you can find a place to fasten the battery here. There's also a washer and nut here for the switch. So the only things that would be sticking up through the surface of our enclosure would be this switch and the two potentiometers. And then we would fasten the speaker up against a hole in the enclosure as well. If your printed circuit board has holes in the edges, you can use this to fasten it down to your enclosure as well. Okay, that's it. Happy circuit building.